All right, so we talked about what vectors are. We talked about one way to report them is to tell you a magnitude and a direction. The second way to describe a vector is to report its components. So basically, the easiest way to think about the components of the vector is that the x component tells you how much the vector points in the x direction. So again, thinking about our vector c here, here's its x component. So in terms of x in this case is our horizontal direction, and so it says to make vector c, you need to go this far horizontally. So this distance is the x component of vector c. The y component tells you how much the vector points in the y direction. So in this case, y is our vertical component. So basically our two components are telling us to make vector c, you need to go this far to the right and then this far up. And this far to the right is known as the x component, and this far up is known as the y component. So one of the things that we want to get very good at doing is to take our vectors and break them up into components. So let's think about our three initial vectors here. So again, we said vector A happens to lie along the x-axis. So one of the nice things about a vector that lies along the x-axis, or any axis, is that one of its components has to be 0. So in this case, vector A, we know what its magnitude is. We know that it lies along the x direction. So the fact that it lies along the x direction means it doesn't point up or down at all. So its y component has to be 0. Its x component then has got to be equal to the whole magnitude of vector A in the right direction. In this case, vector A happens to point in the positive direction. So the x component of vector A is going to be positive 12 meters. The y component of vector A is going to be 0 meters. If we look at vector B, so again, vector B has a magnitude of 15 meters and points in the negative y direction. Again, the fact that it lies along the y-axis means it doesn't point left or right at all, so the x component of vector B has to be 0. So all the magnitude, all 15 meters of vector B, has got to be in its y component. And in this case, that y component will be negative because vector B points downward. So the y component of vector B is negative 15 meters. So if our vector lies along an axis, basically what we're going to do is go through the process where we say, all right, identify which component has to be 0, and then whether the sign of the other component is positive or negative, and the full magnitude goes in the non-zero component. Vector C is a little bit different though. Vector C doesn't point along a coordinate axis, so it doesn't lie along x, it doesn't lie along y. It points up and to the right. So what we're going to need to do for vector C is figure out three things for each component. First, the sign, positive or negative. What's the magnitude of vector C? Again, that's information that we're given. And then which trig function are we going to need to use with an angle that's less than 90 degrees? So what we'll end up doing is we'll saying, here's an angle less than 90 degrees that's easy to define in using a trig function. So notice that we were given an angle relative to the x-axis. So this is going to be information that we come back and use. So when we think about so what that means is that since we have an angle relative to the x-axis, so we've drawn in our 35-degree angle relative to the x-axis, this means that we have literally picked x to be the adjacent side to this angle. The magnitude of the vector itself is the hypotenuse of that right triangle that's made by the x component and y component. So the x component drawn out, the y component draw out, and the vector itself make a right triangle. The x component is going to get the cosine because it's adjacent, it's the adjacent side to this angle since we've defined it relative to the x-axis. So when I think about the x component, sine, well, it points to the right. To the right is positive x, so it's going to get a positive sign. Magnitude of vector C is 20 meters. Trig function, we said given our angle defined relative to the x-axis means that the trig function that goes with the x component is going to be cosine. So the x component of vector c is plus 20 times cosine of 35 meters, which happens to be another way of saying 16.4 meters. We're going to play exactly the same game for vector y. So when I look at the y component, first thing I notice is, oh, it points up. So that means it will also have a positive sign. The magnitude's still the same. So the nice thing about this is that whatever that value is there, it's also got to be the same value in the y component. And then the trig function, well, my y component is now opposite that angle. Opposite over hypotenuse is the sine. So the trig function I'm interested in here is actually going to be the sine of 35 degrees. So my y component will be plus because it points up, magnitude of 20 times the sine of 35 degrees, and that's a distance in meters, which is another way of saying 11.5 meters. Let's pick a third angle, or let's pick a fourth vector. So here's vector d, and the first thing I'll notice is I've been given vector d as an angle from the x-axis. And one of the things that I really want to do is if I'm going to use this formulation for figuring out the components, I want to make sure I use angles that are less than 90 degrees. So the first thing I need to do is pick an angle less than 90 degrees. So in this case, I'll pick the angle from the x-axis to vector d. So from negative x, the negative x-axis to vector d, this is a 65-degree angle. So 245 all the way around, 180 gets you to here, which means you get 65 degrees left over. So now I have a degree less than 65, or less than 90 degrees. Again, it's defined relative to the x-axis. So when I think about that 65-degree angle relative to the x-axis, that tells me that the x component's going to get the cosine again. So whichever axis I draw that angle into, that component has to get the cosine function. So for vector x, well, the first thing I notice is that now, or for vector d, the first thing I notice is that its x component points to the left. That means I need a negative sign here, because I said positive x points to the right, so this component points to the left, its sign will be negative. Magnitude will be 8.5 meters, and then the trig function, 65-degree angle defined relative to the x-axis, so the x component will be negative 8.5 times the cosine of 65 meters. That's another way of saying negative 3.6 meters. For the y component, same game. Here I notice that the y component points down. I said positive y points up, so the y component pointing down means I need the negative sign. Magnitude is still 8.5 meters. Again, the trig function, this angle is defined relative to the x-axis, so x gets the cosine, y gets the sine. So this will be negative 8.5 times the sine of 65 degrees. And again, that's a distance in meters, or negative 7.7 meters. Now you might choose, I happen to choose this angle relative to the x-axis. There's no reason that you couldn't have chosen this angle. It happens to be 25 degrees relative to the y-axis. Right? So you can say, oh, I can also get to vector d by starting here at the positive x-axis, going 270 degrees all the way around to negative y, and then going back 25 degrees. So this still gives me an angle less than 90 degrees, but what I notice now is that this angle is defined relative to the y-axis. So my 25-degree angle is defined relative to the y-axis, which means that in this case, the y component is the one that will get the cosine because this angle is defined relative to the y-axis. This is the adjacent side. So when I think about the x component using this angle for vector d, again, it's still going to be negative x because it points to the left, 8.5 meters, but now it's going to be sine of 25 degrees. But notice that still gives me exactly the same number because the cosine of 65 degrees is exactly the same as the sine of 25 degrees. So it doesn't matter which angle you pick to use here. Both of them have got to give you the same answer. The y component, same thing. Still points down, so sine will still be negative. Still a magnitude of 8.5 meters. Now my 25-degree angle is defined relative to the y-axis, so it's got to get the cosine. and again, it still gives me exactly the same value, negative 7.7 meters. So this is the game that we want to get very good at playing very quickly in terms of breaking vectors up into their components. If your vectors lie along coordinate axes, it's fairly easy. Figure out which component gets 0, what the sign is of the other component, and all the magnitude goes with the non-zero component. For vectors that don't lie along a coordinate axis, like C and D, then I need to figure out the sign, magnitude, and which trig function to use for both components. But that's basically the game that we're going to play.